We are done with Nagios. Today we will start with Docker, right? That's our next topic. Containerization. So yeah. So containerization is what we are going to cover, and Docker is our. It's an important topic actually, but the orchestration part we are not going into for Docker. We will have an introduction about Docker. We will just set up how you can build an infrastructure using Docker. A WordPress infrastructure is what we are going to focus on, and then we will wind up. That's the plan for Docker. It is it's not a advanced training, but enough to get you the basic understanding of Docker and the working of the Docker. That's the intention of this training, right? And we need maybe 2 days of classes or 1.5 day of class actually for Docker. Okay, so containerization is what the principle in which Docker is based in. So before we start with containerization, I will talk about some generic principles of virtualization. Right, the EC2 machines are good examples of virtualization. Actually, when you buy a EC2 machine, probably I may have told you, or you might have figured it out. It's not a actual machine that you are getting. In AWS data center, what they have is a physical machine, and inside that machine, a virtual host would be created. A virtual machine will be created. This machine will contain some CPU. It will have some RAM. It will have some hard disk. It will have the hardware resources, but they are not dedicated resources. They are actually the hardwares shared with the host operating system. The CPU, memory, or the hard disk, it's all shared with the host operating system. That's what Docker is. Got it? So, I mean, that's what virtualization is. Sorry, not Docker. That's what virtualization is. And there are lots of virtualized tools available out there. It's basically what AWS does is they have physical machines. Maybe they are running some Linux operating system. They are the actual physical machines, like your laptop. High, good good hardware machines they have located in their data centers physically, and the machines will have good amount of RAM, maybe some 100 GB RAM, right? Then some 50 CPUs, then a lot of hard disk, some maybe 1 TB of hard disk. So like that, it will have a lot of hardware resources. So when you create a virtual machines, what AWS would do is they will install some virtualizing tools on top of the Linux machine that you have. You will install some virtualization tools, and once you install this virtualization tool, your host machine can actually start holding lots of virtual machines. From this tool that you install, there are different tools out there, like VirtualBox, VMware, then Hyper-V. Hyper-V is from Windows, and like that. Sen, this is a free one. KVM, this is also a free tool. If you install one of these tool into your laptop, you can do that in your laptop also. If you do that in your laptop, then inside your laptop you can actually create multiple virtual machines. So if your laptop has 8 GB RAM and then some 8 core CPU, then you can split that hardware resources into small VMs. You can create one VM that contains one CPU and 2 GB of RAM, another VM that contains two CPU and 4 GB of RAM. Like that, you can create a number of virtual machines. All those virtual machines, you can give a part of your actual RAM. You have 8 GB RAM, you can split that 8 GB RAM into small a small portion, and then assign it to the respective virtual machines. So in this virtual machine, you can install your own operating system. You can install Windows in this machine, you can install Linux in this machine, Ubuntu or whatever. Then here you can install Red Hat, that's under Linux. So whatever operating system that you want to install, you can install the operating system inside these virtual machines. You can have lots of virtual machines inside a physical hardware, depending on how much hardware resources and how much VMs a host machine can hold. Depending on that, there can be zero to a number of virtual machines that you can create inside a actual physical host using one of these tools. So first you need to install one of these hypervisors. Generally they are called hypervisors or virtualization tools. You can install one of them inside your host operating system. Then inside the host operating system, you can create multiple VMs, virtual machines. And each virtual machine will have its own CPU, its own RAM. Even though they are shared with the host operating system, they are assigned. I mean, that is the amount of RAM and amount of CPU that you are going to assign to individual machines. So why do you want to create individual machines, individual VMs? Let's say you need to run Tomcat, you need to run Apache, you need to run database. We can just run everything on a single machine. That's also fine. You can install Apache here. On the same machine, you can install Tomcat. On the same machine, you can install MySQL. Then this host machine has 20 GB of RAM and 20 core CPU. Then these tools installed in it can actually run on the same machine. That's okay. Then why do you want to create virtual machines? The virtual machines provides you a good level of isolation between your applications. Let's say you have a big host machine, you create a virtual machine and you will run Apache inside this machine. Your WordPress page, everything will run inside this VM. You create another virtual machine, and inside this virtual machine, you will set up Tomcat. And basically, you are isolating your different applications by creating separate virtual machines. So even though without having to purchase a separate machine, you could get the level of isolation between the machines, which is a good advantage of virtualization. And that is the reason virtualization is there altogether, right? You need the virtualization um, because of these things. Okay, so that's what virtualization will do. But always remember, each machine have its own operating system installed in. Whenever you create a VM, right? Maybe the same way you would install the operating system in your laptop, you have to install that in the VMs also. You need to boot from a CD, or you need the ISO file of the operating system, Ubuntu or Windows, whatever ISO files, you need to get it, or you need to get the CD, the installation CD. Then using that CD, you need to boot the machines and you need to install the operating system individually. And each machine will have its own kernel, its own operating system, its own binaries and libraries, and on top of it. So basically, they will look like an actual machine. They are actually look like an actual machine, but of course, it is physically it's not there, but they have everything a normal machine will have. But there is a overhead if you follow this method. For running individually operating system on all these machines would need a lot of resources, right? For managing a operating system, the virtualization tool need some memory and CPU. It's a waste, right? So even though you are getting a good level of isolation, actually it is the virtualization which changed the way how people used to manage their infrastructure. Earlier it was some 10 year back when I started working, right? At that time it was the cloud was not very popular back then. So it was all about uh, hard physical machines. People will buy dedicated servers from data centers and they will connect to that dedicated servers, and they will set up a number of dedicated servers and manage the infrastructure in that way. That's how people used to do that back then. And virtualization was there still, but it was again popular also at that time. So virtualization changed the way people used to work, right? It really made a lot of change because people need some 10 or 15 machines because they have lots of software components in it. they can simply buy one or two machines, maybe two machines, two physical machines, and then create the VMs inside those machines. And this is your one Apache machine, this is the second Apache machine. If this is down, the other machine will be up. This is your one Tomcat machine, there you have another Tomcat machine here. So if one is down, the other will be working. So this way you can have maybe only two machines you have total, the physical machines, but through virtualization you have maybe 20 or 50 machines, and you get the good level of isolation with a very moderate cost. And yeah, so this was the advantage which virtualization bring in. And basically virtualization is the key to cloud computing, right? It is because of virtualization the cloud computing term even got started. You know, even what AWS does is they virtualize all their machines that they have. They purchase a lot of physical host machines and they would install some. They use Sen or KVM. These are the two hypervisor tools that they are using. They are free tools. So using these tools, they install these tools inside their physical host machine, and using these tools they are creating the virtual machines. That's what they do. So internally, whenever you create a EC2 machine, it could be a VM created inside KVM, or it could be a VM created inside Sen, and these are running on a hardware resources. That's what AWS will do in the back. So this virtualization started all these cloud computing. People started using these tools, and then they started virtualizing their environment, and then they started selling these virtual machines as cloud machines to people. And that's what you do. You purchase cloud machine from AWS. In fact, it is nothing but a virtual machine that AWS internally manages using one of these hypervisors. Bare metal surveys are actually again some new hardwares, right? New sets of hardwares which are in production today, which are highly efficient for uh, data center operations. Karthik. Yeah, so
Vasu,
that's yes.
just a small question. So, do they install a cloud on, I mean, virtual machines on bare metal servers, or it's just like a very dedicated server for the customers in the cloud?
It's up to them. The thing is that we as a customer don't really care, right? Earlier, AWS, when they started, they had the best machines at that time in the market. And as the years pass, they keep on upgrading their surveys with the latest hardware that comes into the market. It's a continuous process, and it is completely up to AWS to manage their platform. As a customer, we don't care. Maybe
Okay.
they are using some tool to give you a virtualized network. They use some
Mhm.
hypervisors to give you the VMs. The ultimate thing is that you don't care,
Oh, okay, okay.
right? Yeah. So that's pretty the thing about virtualization. But again, the virtualization is still an overhead. There are various reasons for that. So think about AWS. The advantage would include maybe AWS will have some thousand machines in their assume thousand or maybe 10,000 machine they have in a single data center. In Mumbai, they have many data centers, and in one data center, they have some 10,000 machines. If they virtualize these 10,000 machines, they can actually create maybe 10 lakhs of machines, right? The EC2 machines of different people. So that's the advantage with. So they maybe within a small room they can accommodate all these machines because there is only 10,000, right? So that give a lot of advantages physically, right? The place wise, right? And then the infrastructure wise, you need very less AC and very less uh, power if you have only 10,000 machines. compared to 10 lakh machines. So these advantages had brought in, which changed the way how the infrastructure is used to work actually. But again, is VM a overhead? Yes, it is. You have a physical machine, then you are creating 10 virtual machines. All of them will run its own operating systems. So running those operating system itself would give a lot of overhead, right? I mean, it need a lot of CPU and memory. So it is an overhead actually, because every machine, this is running Ubuntu, this is also running Ubuntu, but they are separate machines. Think about that. So whatever things Ubuntu need should be there in this machine, or whatever thing Ubuntu needs should be there in this machine also. And lots of duplication. This is a Red Hat machine. Even Ubuntu is also Linux, Red Hat is also Linux. Most of the libraries and binaries are shared, are common, but still, if you install any operating system over here, it need the full operating system inside the virtual machine. It's completely isolated to each other, not just the application that you're installing. The complete machine is isolated to each other when you follow virtualization. You install Apache here, you install Tomcat here. Yes, they are running in a separate machine, which is great. That's what you want. But you are installing the complete operating system here, the complete operating system here, not something that you would prefer to do, right? It is a overhead. You don't really need the same set of libraries and binaries to be kept in all VMs that you are managing, which is an overhead, right? So that is one problem this virtualization had. And a solution to this problem is containerization. containerization Containerization is more like you get all the advantages as you get from virtual machines. You can isolate different applications without the overhead of virtual machines. So I will talk about it. Docker is an example for this. Docker is the widely used tools in containerization. It's one of the most popular tools out there in DevOps. So what is containerization? You have one machine, maybe a VM or maybe a physical host, whatever. You have a machine. Then you create small machines. These are all Linux machines. Currently Windows is not supported. It is supported, but it is again an overhead. It does not give you the advantages. Uh, you have a number of Linux machine that you have created inside a physical host machine. And inside each machine, you run Apache here, you run Tomcat here. The different applications you will isolate. MySQL you will run here, right? Some caching you will run here. Then this will be your load balancer machine. So like that, you have different containers. They are called containers. But not all these containers, even though this could be a Ubuntu container, this could be a Red Hat container, this could be again one another Ubuntu, this is CentOS, and this is another Linux operating system. So there are number of, it will look like a machine that has a operating system, but actually it is not. The operating system is shared across the VMs. Basically, like I said, the Linux machines has a lot of things in common. The binary files, the libraries, all these things are actually shared across different Linux, whether it is Ubuntu, whether it is Red Hat, or if it is CentOS, doesn't really matter. For different operating system, there are most of these binaries and libraries are shared. There are only few custom ones that you need to have in individual machines. So in containerization, what all these containers does is, whatever shared binaries and libraries, it would be shared. It would be shared with the host operating system that contains Linux, and all these containers will run what they want. Maybe some custom binaries and libraries which are specific to Ubuntu would be contained inside Ubuntu server. Some custom libraries and binaries that are required for CentOS would run on this container. So like that, what is required will only run inside the container. Or you want to install Apache will run inside the container. You want to deploy WordPress here, WordPress will run inside the container. You want to install PHP will run inside the container. So whatever custom application or software that you want to install, they will run inside the container, or the other shared libraries would be shared with the host operating system. So that's what containerization is. What it means is you don't have the overhead of VMs. You don't, even though it will look like virtual machine, you can log into this machine, you can connect to this machine through SSH, you can execute the command bash, then you will get access to the bash shell. You can run the Linux commands over there. They all commands will work. You can install Apache by running apt-get install Apache 2. You can install Tomcat by downloading Tomcat and then exporting the path. Whatever that you can do inside your EC2 machine, you can do the same thing on the container, but the containers are not actually separate machines. Got it? So you are getting the same level of isolation using the container without the overhead of virtual machines. So what you do, take a machine, maybe your EC2 machine is good enough, install Docker in this machine, and there is a kernel, of course. When you install Docker, the kernel is updated with the Docker stuffs, right? And you are creating containers inside. This is a Apache container, WordPress container, MySQL container, like that. You have Tomcat container, you have different containers out there. All these containers are managed by the same kernel, right? The same host kernel. There is no individual kernels in each machine. You won't find any kernel. There is only single kernel which is residing in the host operating system, which will manage all the machines. All these machines will actually run like a software, right? That's how a process runs, right? How a process would run in Linux. They run, even the containers run just like a process. Whenever they need some memory, let's say lots of connections are coming to Apache, this is the Apache container, and lot of connections are coming to Apache, and Apache need more CPU and memory to process all the requests. Then the kernel running in the host machine will identify that requirement, then give the memory to that machine, or enough memory or CPU to that machine. So based on what the containers need right now, a single kernel will manage all these containers. Think about that. Perfect, right? So let's say in MySQL you have very less load. There are not too much load coming to MySQL, but there are lot of load coming to Apache. The kernel would identify that, okay, this machine doesn't need much memory. It will take out the memory from that machine, assign the memory to this machine. So basically the memory would be managed just like the way how memory is managed across multiple process running in Linux. So containers will appear like a process to the kernel which is there in the Docker host machine. Maybe this is nothing but could be your EC2 machine. Inside this EC2 machine you install Docker, and the kernel will be modified, and this kernel will manage any containers that you are going to create inside this Docker host machine. Is there a standard container format to divide the OS? Containers does not divide the OS at all, right? That's the whole concept of containers, right? The machines, the operating systems operations, you are running some command, ls command you are running inside this container. The ls command is probably actually located inside the actual physical machine. It will take the ls executable, shared executable from the host machine and execute it inside the container. That's how it works. How many containers can create? We can create any number of there is no limit how many containers that you can create. The limit would apply, of course, if you don't have enough CPU and enough memory, and you are running lot of containers, and all these containers are getting lot of traffic, right? So it completely depends on uh, the usage, right? Like I said, there is no CPU memory overhead when you work with the containers. No containers need its own dedicated memory or CPU, right? They need only the processing power, because you are running only your custom applications inside the container. So how much memory or CPU the application want, that should be there in your host machine. Apart from that, there is no limit how many containers that you can create inside a single Docker host. Padmaja, yes. They can communicate each other. Can these containers communicate each other? Yes. All these containers will get a virtual IP. Whenever you set up Docker, a virtual network would be created across the multiple machines, and they can communicate each other. We will come to that. Docker support
Uh,
multiple OS, but only Linux as of now. Uh,
uh,
Faisal.
Basil, just a quick question. We can't share multiple resources from the various servers, right? Like we do it on a virtual machine. Like we can have two or more servers combined together for having virtual machines. But with container, we can't do that, right? We need to get these, CPU resources, everything from the same server. We can't share it from the other server.
Containers, right? Yeah, for the containers, you don't really assign a dedicated CPU or memory. The reason you don't do that is you don't need to, because as long as the host has enough memory, think about that. How a Linux kernel will work? It's a kernel, and there are number of processes running inside your machine. Kernel will look at each process. If there is available memory, it will assign the memory to the process which require the memory. And then the another process request for memory, it will give it to that process. So it's the single kernel that takes care of the memory management for individual process. The same concept apply to containers. Let's say another process is now requesting for some 1 GB memory, but there is no 1 GB memory left in the RAM. What will happen? The process will be killed. That's what kernel will do. Kernel will kill that process because there is no enough memory in the kernel. The same concept applies to containers, right? If any container is not able to, right, there's a high load coming into the container, the kernel will take care of that. The kernel will make sure that your entire machines is not getting overloaded. It takes care of memory management on a dynamic way, just like the way how process work in Linux. It means it does not require boot of OS. No, it doesn't need a boot of OS, right? The machines are not booted up or anything. You want to run a container, just run the command to start the container. It is started in less than a second. That's the time you need to. It's like literally they are processes. Literally they are actually nothing but like a process which is running in your Linux machines. That's what a container is. Even though it will look to you like a separate virtual machine, they are not. So we will come to that. I will show you the creation of containers. They don't need to be. You cannot reboot the machine, right? Because it's not a machine. Can you boot the operating system inside this machine? There is no operating system inside the machines. So just to answer your question, Faisal. So we will come to that. We will, as we start with practicals, it would become because it is kernel correct, right? And the kernel is in the host operating system. So this is the difference diagram that shows the difference between VM. If it is a VM, you take the physical host machine, you will install some operating system, right? In your laptop, you are running Windows or maybe Linux. Then you will install the hypervisor like VirtualBox. Then inside the VirtualBox, you create the VMs. The VMs will contain its own operating system, its own binaries and libraries, its own application that you deploy inside it. So like that, each VMs are separate machines. Right? That's not the case with a container. In the container, you have a physical host machine. You will run a operating system inside that machine. Then you install Docker in it. And this has to be a Linux operating system. Currently, it is supported in Linux. And you install Docker in it. Then you create the containers. All these containers does not have separate operating system. What they does is the binaries and libraries are shared across the host machine and the other containers. So that is the difference between a kernel and a virtual machine and a Docker. Okay, so we will begin. So first I will create a machine, EC2 machine, which I will use as the Docker host. Yes, select Ubuntu. T2 micro is good enough. Okay, this is the Docker host machine. I will log into this machine and I will install Docker. So I created a EC2 machine. This is going to be my Docker host. I will install Docker in it, right? I will install Docker in it, which then I can create small containers inside my Docker host or the EC2 machine. So let me go ahead and install Docker in it. First, let me log in. apt-get update command. First, I am running this. This is some Linux kernel module. First, I need to install some kernel module which support virtualization. So before installing Docker, I need to make sure that my Linux system, the Docker host machine, support virtualization. For that, I am installing some virtual module into kernel by running this command. Okay, now I'm going to add the Docker key. This is some, I don't know if you know about, this is some digital certificate. You are adding some digital certificate to make sure that when you install Docker, you are installing the right package. That's what this digital certificate will make sure. I'm simply adding that into my repository. Now run the command apt-get update. Install Docker. apt-get install Docker, docker.io are the packages that you want to install. Okay, Docker is installed now. So the main part of creation of containers is an image. It's just like AMIs in AWS, not exactly AMIs. AMIs does contain an operating system. The Docker image does not contain an operating system. That's the difference. So you want to create a Ubuntu container. You want to download a Ubuntu image. Then using that image, you create your container. You want to set up a WordPress itself. Sometimes you don't want to set up a Ubuntu server. Your requirement is a WordPress. You simply want to download a WordPress image. From WordPress image, you can create a container. This container will contain Apache and WordPress, everything. You want a MySQL container. You download the MySQL image first. From the image, you create the container. So like that, first you need to download the image, which would contain these custom libraries and binaries specific to the software that you're looking for. If you want a plain Ubuntu operating system, then this image will contain only the libraries and binaries specific to Ubuntu. Then you want a WordPress, this image would contain only WordPress files, Apache software, and some binaries and libraries that are required for Ubuntu or whichever operating system that is WordPress is in, that way. So what I am going to do is I am going to download a Ubuntu image. There's a place where you can download the images, hub.docker.com. Hub.docker.com is the place from where you can download the Docker images. You can see Ubuntu image, WordPress image, like that. You can see different images. Click on the explore button. You can see the list of images that you can have. There is Alpine, Nginx, HTTPD, Redis, like the Ubuntu. There are different operating system that you would see over here. Not just operating system. Let's say you want Apache. HTTPD is also nothing but Apache only. Or you can search for Apache 2 if you want a container that runs Apache 2. Search for Apache 2. You will find some container. This is a container that contains Apache 2. This is another container that contains Apache 2 as well as PHP 5. Right? You want WordPress, you can search for WordPress. You will get a container that come along with WordPress. Right? So you can choose to download any images that you want. Sorry. Search for Ubuntu. This is the Ubuntu official. Click on the image, it will open. Here you can see this is the command you need to run if you want to get the image. Docker pull Ubuntu is the command you need to run to get that image on the Docker host machine. So inside the EC2 machine, I install Docker. Then I am downloading the Ubuntu image. Using this image, I will create a container, a Ubuntu container. But of course, always remember it does not contain the full operating system. Okay, it is very small in size. Actually, the images are typically some 120 MB or hardly 130 MB. That's all. They are very small in size, right? So run the command docker images. It would show you the list of images that you have. Right now you have only one image, Ubuntu latest. Tag is nothing but which version of Ubuntu image that you have downloaded. Over here, if you click on tags in the hub.docker.com, you can see different tags here. Mm, right, you can see it's okay, latest, Senial, right, like that. Oh, come on, you can have different. If you want 14.4, then you can put 14.4, Ubuntu colon 14.4. If you put it, then this is the operating system which will get downloaded. So you can choose which one you want to download. It's up to you. As you can see, the size of image is only 112 MB. That's it. Of course, that's all it's supposed to have. So now I want to create a container from this image. The image is downloaded. It is available on my Docker host. Using this image, I am going to create a container. The command to create the container is docker run space the image name. Let's say your requirement is docker run Ubuntu. Uh, Put hyphen ti. Then you want to execute a command. Let's say you want to execute any command. Let's say ls slash home. Right? You want to execute this command inside your container. So basically, what this command does is it will create a container from the image Ubuntu. Then run this command inside your container. Let's see what happens. It would basically show you the contents of slash home. No such file or directory. Maybe I will simply put ls slash. There is no folder called home inside the container, is what it is saying. Maybe it is true. I just put ls slash instead. I simply put ls slash. Mhm. Or simply type ls. Okay, it's working. So I execute the command ls. It is showing me the content of inside the container. Inside this image is what it's showing. So the files inside the container it will show. I run the command bash. I will be connected to the bash shell. Even the bash is also comes along with the image. So run the command bash. You would be connected to the bash shell. Right? Run this command. You are connected to the bash shell. Now you are inside the container. As you can see, this is nothing but your container. So that's all it takes. Less than a second, you are connected to the bash shell. You want to execute some command, let's say ls, you can execute it. It will work. So these commands you are running inside the container. You want to go to home folder, cd home will take you to the home folder. You want to type ls, it would show you the content is inside the home folder. So you can work like you work on a normal operating system. You want to run the apt-get update command, you can run it. You want to run apt-get install Apache, then Apache will be installed inside the container. You want to download WordPress files into www.html folder of container, you can use wget to download. So all the Linux commands will work inside the container. You can customize your container the way you want it by working with the bash shell, or making changes by running commands in the bash shell. You want to install Apache, run the command apt-get install Apache, then Apache will get installed. Docker image is stored inside the host machine, Docker host machine. So basically right now I am installing Apache inside the container. So I can do whatever I want. I want to download WordPress, I can download WordPress here. I can do whatever I want inside the container. Now let me log in once again to the host machine. This is the host machine. And you have class tomorrow. I mean, tomorrow in the sense 7 a.m. IST. What it means is 9 hours from now, we will be covering uh, Python programming tomorrow. That is the plan. Okay. Uh, so it's actually 9 hours from now. We are covering Python programming. Okay. We will take a day off on Monday. Right. Mm. So, yeah. And if anyone miss Python programming classes, that is tomorrow, please let me know on Tuesday in our regular classes if you have any problem. Yes, we are covering Python this weekend. Actually, Saturday and Sunday we are covering Python programming. So what it means is the Saturday, I meant to say Indian time Saturday. Those who did not take Python classes, please take the Python class. I think few of you have already taken Python classes, right? Yeshwant, you have taken, but few of you have not taken Python classes. So those who haven't taken Python classes, take them. Take them Saturday and Sunday. Next class is actually 9 hours from now. It starts at 7 a.m. IST Saturday. That means 9 hours from now. For US students, it's Friday itself, Friday evening. And if anybody miss the Python classes, let me know on our next regular class, which is going to be on Tuesday. Our regular class is going to be next class is going to be on Tuesday. On Monday, you can take a day off. Tuesday, we will continue. If you miss the Python classes, let me know. I will make the list of people who missed it and give it later. Yashwant, we covered shell scripting, right? I think all of you have taken shell scripting training. Did anybody miss shell scripting? Yeah, I think nobody. Did we cover shell scripting? We didn't cover shell scripting.
No, we didn't cover shell scripting.
Okay. Then tomorrow we will cover shell scripting. Tomorrow let's cover finish shell scripting. Okay. I thought okay, got confused. Yeah. Tomorrow we will cover shell scripting. That means 9 hours from now we have class. We will start with shell scripting.
Basil Dinesh here. Earlier we had a session on shell scripting, meaning like I have attended it during the end of November. Is it going to be the same session?
Yes.
Okay.
If you have taken shell scripting, no need to take it the weekend classes. But
Fine, Basil.
I think most of you haven't taken it. Okay, yeah. So now I logged into the Docker host again. Not yet. I'm going to log into the Docker host again. Docker images is the command which would show you the list of image. Then Docker ps is the command that will show you the list of containers. Docker ps is the command that shows you the list of containers. Right now you have one. This is the container ID. It is created from the image Ubuntu. Bash is the command that is being executed there, right? We connected through the bash shell. This is the one. And we also installed Apache inside the container also. It was created 7 minutes ago. So all this information you can see when you run the command docker ps. You want to stop a container, you can run the command docker stop. It will stop the container. Docker stop, sorry, it should be docker stop space the container name. That's what you need to put. Docker stop, then put the container ID. That container will get stopped. Now run the command docker ps. Now run the command docker ps. It's gone. It's actually gone. So this way we can create the containers and track them by running the docker ps command. You can see the list of containers that you have. So that's Docker Compose. We will cover tomorrow, not tomorrow. In our next regular class, we will cover Docker Compose. In weekend, we will finish shell scripting. Saturday and Sunday, you have classes at 7 a.m. IST. So it would be 9 hours from now, the first class. Then again, 7 a.m. Sunday, you have the second class of shell scripting. We will cover shell scripting in 2 classes. That is the plan. Okay, so once we covered that, then Monday you don't have regular classes. You can take a day off on Monday. Tuesday you will have regular classes. We will continue Docker from there. That is the plan. So can we use kill command instead of stop? I don't know if there is a kill command there. Could be. Docker stop is what generally used. Basically, a stop command will terminate the container. That's what it will do. Yeah, kill is also one command that you can use. That will delete the container. Dinesh, yes, I will do. So
Yes, sir.
I hope you are